Welcome to a lesson on dividing decimals. The goals of the video are to divide a decimal by a whole number and also to divide a decimal by another decimal. Let's do a quick review on some vocabulary. If we have C divided by B equals A in this form or long division form, C is our dividend, B is the divisor, and A is the quotient. So the procedures for dividing by a whole number are to place the decimal point in the answer directly above the decimal point in the dividend and then divide as we normally would. So we'll go ahead and rewrite this in long division form, and because this is a whole number, we'll move this decimal point straight up into our quotient or our answer, and now we'll divide as we normally would. So we ask how many 4s are there in 15? That would be 3. 3 times 4 is 12. Remember, we subtract. Bring down the next digit, which is a 2. How many 4s in 32? That would be 8. 8 times 4 is 32, and we have a remainder of 0. So our quotient is equal to 3.8. Let's go and take a look at one more of these. Notice we're dividing by a whole number, so we'll follow the same procedure. Move the decimal point straight up, and now divide as we normally would. So how many 3s are there in 4? That would be 1. 1 times 3 is 3, and we subtract. Bring down the next digit. How many 3s in 12? That would be 4. 4 times 3 is 12. That would be 0. Bring down the next digit. That would be 2. How many 3s are there in 2? Well, there's 0 3s in 2, so we put a 0 here, and we multiply, and then we subtract. Now we can't stop here and say there's a remainder of 2 or even 2/3. We have to keep dividing until this decimal terminates or starts to repeat. But now, since we're out of digits, we can add zeros to the right here and not change the value of this number. So we add a 0 here and we bring it down. How many 3s in 20? That would be 6. 6 times 3 is 18. And we subtract. We need another digit, so we add another 0 and bring it down. How many 3s in 20? Well, we just asked that question, and that was 6. 6 times 3 is 18. We get 2. Add another 0, and you can kind of see what's happening here. We keep getting 20. Therefore, this 6 will continue to repeat. And so what we can do is say the quotient is 14.06. Since the 6 repeats, we put a bar over the 6. Okay, now let's talk about how we're going to divide a decimal by another decimal. If the divisor is a decimal, we change it to a whole number by moving the decimal point to the right as many places as necessary. Then we're going to move the decimal point in the dividend to the right the same number of places. Once we complete step 1 and step 2, it's the same as we did before. We'll place a decimal point directly into the answer, and then we'll divide as we normally do. So what this rule is telling us to do is if we have a division problem like this, this divisor must be a whole number. So we can move the decimal point to the right once, as long as you do the same to the dividend, so moving this between the 8 and the 9. So the division problem we'll perform is 68.9 divided by 13. We'll move this decimal point straight up and then divide as we normally do. Now I want to take a moment and explain why this actually works. We all know that 6 divided by 3 is equal to 2. Well, if we multiplied the divisor by 10 and also the dividend by 10, we would have 60 divided by 30, and you'll notice that the quotient is still equal to 2. So as long as we multiply the divisor and the dividend by the same number, it does not affect the quotient. Another way to look at this would be in terms of fractions. If we took the original division problem and rewrote 1.3 as 1 3/10 in fraction form, and then rewrote this as 13/10, we would have 6.89 divided by 13/10. Remember, when you're working with fractions, you normally multiply by the reciprocal instead of divide. So dividing by 13/10 is the same as multiplying by 10/13. Now watch what happens when we multiply the numerators together. We have 68.9 and our denominator is 13. Well, lastly, remember that a fraction bar is just a division symbol. So what we've shown here is that 68.9 divided by 13 is equivalent to 6.89 divided by 1.3. Let's go ahead and try a couple of these. Let's set it up in long division form. So the rule says this has to be a whole number, so we'll move this to the right once, as long as we do the same to the decimal point here. And this is a little messy, so let's go ahead and rewrite this so we can keep track of where the decimal is. Now we'd have 670.8 divided by 26, move our decimal straight up, and now we divide as we normally would. So we need to consider how many 26s there are in 67. Now that's not a very easy question. What you can do is round this to 30 and round 67 to 70 and ask how many 30s are there in 70. So let's go ahead and try 2 and see if that works out. 2 times 26 would be 52. Remember, as long as this difference is less than 26, this 2 would be correct. Looks like we have 15, therefore this 2 is correct. We'll bring down the next digit. Now we want to determine how many 26s are in 150. Again, we can think of this as 30. How many 30s in 150? That would be 5. Let's try 5. 5 times 6 is 30. We carry the 3. 5 times 2 is 10 plus 3. That'd be 13. This is 20, less than 26, so that 5 is correct. Now we'll go ahead and bring the next digit down, which is an 8. This is still a fairly challenging question. How many 26s in 208? Let's ask how many 30s there are in 210. So we'll put a 7 up here and see how that works out. 7 times 6 would be 42. Carry the 4. 7 times 2 is 14, plus 4, that'd be 18. Now what happens when we subtract here, we have 6 and then we have 26. That tells us that this 7 would not be correct because this number has to be less than 26. But since the divisor and this remainder are exactly the same, that's telling us if we change this to an 8, it should come out perfect. Let's go ahead and give it a try. So we put an 8 here, and then go ahead and erase this. Now we'll multiply. 8 times 6 is 48. Carry the 4. 8 times 2 is 16, plus 4, that'd be 20. And we have a remainder of 0. Therefore, our quotient is 25 and 8/10. Let's try one more of these. Let's go ahead and write this in long division form to get started. Remember, the decimal on the 12 would be at the end. This has to be a whole number, so we'll move it to the right twice this time. And we'll do the same here. We'll have to add a couple zeros. So the division problem that we'll actually perform will be 1,200, the decimal point here, divided by 36. We'll move this up and start dividing. So the first question would be how many 36s are there in 120? Again, not a real easy question, but we could think of this as 40 and this as 120, and there'd be 3. This may or may not work, but we'll start with this. 3 times 6 is 18. Carry the 1. 3 times 3 would be 9 plus 1, that'd be 10. Looks like we'd have 12, so that's good. Bring down the next digit. How many 36s in 120? We just asked that question and there was 3. And 3 times 36 was 108. Subtract, that's 12 again. We need to start adding digits now. Bring down the 0. How many 36s in 120? Well, that's the third time we've asked that now. And you'll notice we keep getting 3s. So this 3 is actually going to keep repeating over and over again. Therefore, our quotient is 33.3 with a bar over the first 3. Okay, I hope you found this video helpful. Thank you for watching.